Good afternoon, everyone. It is my pleasure today to introduce Alan Tsang, who is an associate professor at the School of Computer Science at Carleton. Alan received his PhD at the Sheraton School of Computer Science at Waterloo with Dr. Kate Larson and completed a postdoc at the National University of Singapore with Dr. Yer Zik. Alan's primary research is in multi-agent systems, and he is particularly interested in areas with socio-technical applications such as computational social choice and social networks. Alan also has an interest in AI ethics pedagogy and experiential learning techniques, which I am happy to say we are going to be hearing about today. Alan is going to talk to us about the use of science fiction in such pedagogy, which is a personal interest of mine. So I'm extra excited for this personally. I'm sure plenty of the rest of the room is as well. Alan, thank you so much for joining us.
Thank you for having me here. It's very exciting for me to give this talk. Thank you for the excellent introduction as well. So I am an associate professor at Carleton University. I do multi-agent systems research. Historically, I've been interested in topics such as voting, fair division, social networks, and modeling sort of human behavior within these systems, which you could summarize as social technical systems. Recently, I've been doing just some of my more recent work. I've been looking at gerrymandering models with an element of social influence in it. I've been modeling sort of the effects of implementing the Canadian AI and Data Act on how that might reshape markets. And I also have a work on economic models of aging workforce. So all of these sort of have in common this idea of social technical systems, right? I think it should be not a surprise to this group that computing technologies have been really changing the world, and AI technologies are increasingly integrated into all aspects of society. And we can define social technical systems as systems that have both a technical component, which we call the AI component, but also interface with people in some way. And when I was sort of doing my PhD, I was really drawn to this idea. I thought that was a fascinating combination of things to study together. And historically, that's meant things like recommender systems or social networks or social media platforms. And there's been kind of a relatively clean separation maybe of the social and the technical parts, but that's becoming less and less the case now, right? The social and the technical are increasingly co-mingled with each other to the point that often we, the social, have trouble getting away from the technical bits, even when we do want to do that, right? And uh, it's important for us to sort of integrate a more comprehensive way of teaching things like responsible AI because the computer science students of today will be designing the infrastructure that will set the stage for all future social, economic, and cultural interactions. Right? And I think it's hard to understate the importance and the far-reaching consequences of the work that students today will be doing in the future. Right? And there is an increasing urgent need to for computer science education to provide the kind of training that will allow the students to be using this power responsibly and to appreciate the impact they will have on the world. I'll note on the sidebar here that the ring controversy, right, has been at least temporarily resolved, right? This particular story is no longer current. Well, it was when I made this slide. That this particular the integration of Ring into a surveillance network has been stopped. So I give it 50-50 chance that it will resurface in some other way in the next few years. The pedagogical goal I want to talk about today is something I call a multi-agent perspective. A multi-agent perspective means an appreciation that the world is messy and complicated, and there are many things moving in it that cannot be simplified to a simple optimization problem, right? As much as that is a temptation of from a sort of computing education. And to foster a sense of empathy, in the sense that we appreciate other people in this world, and also that other people might have different perspectives and different preferences. And that your actions will impact these other people and potentially change the way that they behave in the world. Right? And so this work is based on two courses that I teach that now have their a paper associated with each of them, a upper year computing society and ethics course that has that's part of an experience report that will be coming out actually next week. There's going to be a presentation next week at SIGC. That's the special interest group on computer science education. I mean, it's just coincidental that we had the same sort of tail acronym there. And also the my multi-agent systems course, which is a cross-listed course that has graduate and undergrad. It's my research course, and I use an experiential learning activity there. And this paper came out last week, and it was just, or actually a few weeks ago. I just came back from that conference last week. So these are fresh off the press. So first, I'll talk a little bit about what multi-agent systems is, or introduce that area of research to you, and then we'll talk about sort of the science fiction part and the experiential learning part. Right? So it's a bit of an odd way to sort of start a responsible AI talk, but hypothetically speaking, let's say you and your friend, in quotes, robs a bank, right? And then the police come and round you up, and you are separated and interrogated, and you have one of two actions, right? This is classic prisoner's dilemma. I imagine probably two-thirds of you already know this. But you can now, you have one of two actions to take. You can either confess and rat out your friend, or you can stay silent and hope that your friend also is staying silent, because if you both stay silent, it turns out the police don't have enough on you. You get sort of the bottom right outcome. You get kind of, you just a slap on the wrist, and you get to go. However, if you rat out your friend and your friend stays silent, that's kind of the best outcome for you, because now you get to go free. You get 0 years, and your friend in quotes, right, gets a very long prison sentence, right? And if you both confess, then well, now the police have everything on you, on both of you, and both of you go away. But not as long, not for as long as um, if you were the one to remain silent and then got ratted out, right? And of course, your friend is also, again, friend in quotes, is doing the same computation on the other end. Right? They are also thinking about what they should do in this particular situation. Um, Prisoner's dilemma is something we introduced sort of in the first class of multi-agent systems. It really encapsulates a lot of the underpinnings of this field. We'll come back to the prisoner's dilemma. I just want to situate multi-agent systems within AI, and there's many different definitions of what AI means to different people. We'll use this particular one, that AI is the study of rational intelligent systems. I mean, it's hard to say that that's not what AI is. We are looking at how to solve problems, right, using rational, intelligent ways. Um, Within AI, there are many pillars. And machine learning is only one of these pillars. Within machine learning, we have like what was called deep learning or neural networks. And then within that, we have the new hotness of generative AI. But there are other pillars in artificial intelligence as well. We have like the family of pillars of what's called good old-fashioned AI. And then we also have multi-agent systems, right? Multi-agent systems is what happens when you think about a collection of these AI systems or intelligent systems working together? So let's say you have a robot, right? Here's a robot. This is classic AI in action. The robot thinks about, okay, I would really like this blue box at the bottom. There are other these boxes above it, right? So what does it do? Well, it needs to figure out, okay, I need to move these other boxes out of the way one at a time, right? And now I have the blue box I was looking for. Fantastic, right? This is the state of artificial general intelligence as of about like the 70s, right? This is like the robot knows how to move boxes out of the way and can pick up boxes that it wants. Great. What happens when you have multiple robots? Multi-agent systems is the study of communities of these rational intelligent agents. And these rational intelligent agents are all acting, well, intelligently, strategically, and you have to reason about what the other agents are reasoning about in order for you to act effectively into this space, right? This robot here is thinking, well, maybe I shouldn't move those boxes out of the way, because what if the other agents take the box that I actually want at the bottom? So that's what multi-agent systems is about. And again, as AI becomes more broadly deployed throughout society, it becomes increasingly important to be reasoning about the interactions between these agents. And by these agents, I mean both human agents as well as AI agents, and all kind of pairwise interactions between these, right? All of these fall under the purview of multi-agent systems. Economist Axel Okenfeld calls this equilibrium thinking. Mm. And these agents, of course, are not, these AI agents are not deployed in a vacuum. They will become part of a social technical system, right? There's this idea that they are commingled with the rest of society. And so understanding what the rest of that society, the human perspective, becomes increasingly important as well. Like that forms, multi-agent system forms the sort of technical basis for um, the multi-agent perspective. And multi-agent systems sort of has a foundation in economic game theory, right, which originally studies games of chance. And we look at things like voting, auctions, and fair divisions, right? How do we allocate resources? How do we make group decisions? How do we allow markets to form, right? How do we create markets? And multi-agent systems often has a computational focus or approach or utilizes computational theory or simulation tools to sort of examine these problems. And for a while, I sort of had this core, well, I had my research field in multi-agent systems, and I started teaching this ethics course. And I was really into both of these, and I couldn't really tell why. I was just very drawn to both aspects of it, and, until one day I realized, these two somewhat disparate fields are answering the same question. Multi-agent system says, in a complex system, how should you act, right? According to mathematics and game theory. Well, ethics is also answering the same question. In a complex situation, how should you act? But according to ethical philosophy and various domain frameworks. So both of these, I think, in order for you to think effectively about them, requires an appreciation of this multi-agent perspective. Okay. So I'm going to go through sort of the first course that sort of or talk about the computing, society, and ethics, which is the sort of AI ethics course that teaches. This is an upper year elective course for computer science students, a class size around 60 some. Right? It's based on a textbook called Computing Ethics and Technology, or sorry, Computing and Technology Ethics, Engaging Through Science Fiction. It's right there on the tin, uses science fiction. It's the textbook was written by some of my friends and colleagues. And you'll notice that, well, so I introduced this course in the blessed year of 2020. And you'll notice that there is the dates don't line up, right? That the textbook was only published, I guess, 3 years ago now. And so I had worked with a draft of the textbook after talking to Nick Matei at a conference. I became very interested in this. So I built the course sort of based on drafts of the textbook. There was only some chapters were available, so I sort of filled in the rest of it. It was actually quite fun to sort of come up with this course. So the course has, you could split it down different ways. I split it down to sort of four components here. We have the lectures, right? And then we have the sort of more student-led activities. And it's the lectures that are interesting for us today. So we have lectures on ethical frameworks. We talk about these sort of classic ethical philosophies, virtue ethics, deontology, and utilitarianism. These are sort of very classic things to study when you talk about ethics from a philosophical perspective. And then we also have what I call social technical frameworks, right? These are more domain specific issues within computing, within AI that we also care about. These include data biases and unintended consequences, privacy, and other sort of special topics. And the class also has in-class debates as well as final project and presentation at the end. So focusing on lectures, each lecture is paired with a companion story, right, for both the ethical and socio-technical frameworks. Each lecture has a companion story associated with it. The students read the story before class, so it's sort of assigned in the class previous to it. And these are all short stories with a reading time of only a little over an hour at the top. Most of them are a bit shorter than that. And the purpose of the story is to exercise the concepts from the lecture. Um, and so they go home and read the story. They come back to class, and we have a second class. We see on sort of the schedule on the right that we'll have a discussion class, or we'll have a class devoted to discussing concepts from the story, right? And additionally, we have four assignments and five reflection activities associated loosely with these. The assignments are substantially longer, and the reflections are supposed to be a bit shorter. So why do we use science fiction, or I use fiction in general? Well, humans learn with narratives, right? We intuitively understand what a story is. If you think about like how do we teach young children, it's often with stories, right? We have specific names for these stories, but we have Aesop's, right? These moral stories with a moral sort of lesson at the end of it. So humans are naturally equipped to learn effectively through stories. There's an entire pedagogical technique called narrative-based education. But also, the stories give a sense of this messiness that is in the real world, right? The real world is messy. There are people involved, right? Go to this point. There are people involved. You sometimes care about those people, or certainly when you read the story, you care about the people because that's how narratives work. And it invites the students to draw the same parallel to decisions they might make in the future, right? That their decisions might impact people as well. But more than that, it emphasizes that there's not a clean way to model any situation, and often there's no single best solution, right? And this is the advantage having a fiction has over a case study, right? A case study is very good in that it presents you sort of a list of facts, right? Here is what happened, and here is how what problem was identified, and here is how that was resolved. But it gives it an illusion of cleanness that, oh, okay, these are the only facts that we care about. And that if you encounter this problem, you should solve it this way. Right. But the using fiction sort of disarms this notion that there is only one best solution that you should consider. Instead, there are trade-offs between different approaches. And lastly, but not leastly, it also cultivates a sense of moral imagination, right? It tells the reader, the student, that you should think about the problems that might be caused by this particular solution, this particular technology, to envision potential moral hazards, right? We think of a hazard as a dangerous situation, right? But not necessarily one that yet causes harm, but could cause harm, right? In that sense, there are potential moral hazards that are introduced by technology. The technology doesn't necessarily cause harm, but it could produce a situation where harm is easily caused. So to give you some examples, here is so lecture two for this past semester was on virtue ethics. So virtue ethics, classic Greek philosophy from Plato and Aristotle. And I'm not going to give you, since this is going to be a very short summary of a very complicated topic, right? Virtue ethic basically says there are these moral virtues, and they're kind of like a skill. And like the more you use them, the kind of better you are at them. But also, the moral virtues always exist as the mean between two vices, well, a vice of excess and a vice of deficiency, right? That, for example, being good Athenian sort of examples, right? We have the soldier. The soldier is courageous, but the courage, the virtue of courage exists between an excess of courage, of rashness, right? And a deficiency of courage, of cowardice, right? And it is in choosing this mean that we arrive at the virtue. And one of the important things to take away for us as virtue ethics is that different cultures have different ideas of what that golden mean is situated at. And to illustrate this, we pair it with this companion story called The Machine Stops. This is a short story for E.M. Forster. Um, and it envisions this post-scarcity underground society that humans inhabit, and people live in isolated rooms and only interact with each other remotely. There is this sort of machine, right, that is the society, and it provides for every needs everyone's every needs, right? And it envisions this idea of like teleconferencing, sort of remote medicine. It is the first story to envision tablets, right? Like handheld portable displays, right? Which is fascinating. Um, Also surprisingly, this story was written in 1909, almost 80 years ago. No, more than 80. No, almost 80 years ago. Yeah, almost 80 years ago. This predates television, and this was when like radio was kind of like a cool new thing, right? Yet E.M. Forster envisioned all of these things, right? In very sort of like accurate to modern day times. And so the story itself offers a critique on what it means to be happy, right? What does it mean to pursue happiness? And it cautions against over dependence on technology and the harms that can cause, right? And of course, that is kind of a highly relevant, um, theme today. There's been multiple adaptations of this story. If you Google it, you could find the short story. It's freely available. It's in public domain, I think. And also, it's kind of amusingly, this story was mentioned by Stuart Russell. If you've studied AI, you might have used Russell and Norvig. This is the Russell of Russell and Norvig. And it's mentioned by him in AI keynotes that I have personally attended twice in two different keynotes. So I guess he really likes this story. So in the society that's portrayed in the story, it's kind of a distorted mirror of ours, right? If you read it as I did during the pandemic, that was an extra distorted mirror because we were all like living in pods and using teleconferencing, which is a little surreal when I was reading it. Um, and their society kind of discourages primary experience and familial bonds, and it views physical frailty as something to be praised, right? And that's very different from our society, but it makes sense within theirs. And it really brings home the point that the golden mean for these virtues can be very different for different societies. And it opens the door to discussing concepts of weird cultures of knowledge, right? Weird is an acronym. It stands for Western, Educated, Industrialized, Rich, and Democratic. It's very likely that the majority of our participants today are from a weird society. Um, and weird societies are important to talk about because it turns out most scientific literature is produced about weird societies, from weird societies. Certainly, a lot of the soft sciences have their roots in weird societies, but yet they make up only a minority of Earth's population. Here's another example of another story that we use. This is much later in the course, so um, it's about one of the socio-technical frameworks. This is Better Living Through Algorithms. This is the Hugo short story winner from 2024 by Naomi Kritzer. And is the companion story for the lecture that discusses data biases and unintended consequences. In this story, we see the introduction of a new productivity slash wellness app, right, called Abaleek. And it's endorsed by both like managers who want their workers to use it, but also like the workers themselves also really like it, which is kind of fascinating. Um, and the app leverages some combination of like machine learning and crowdsourcing to help make its users happy, or again, this theme of like pursuing happiness. And there's discussion of like, does it matter who makes this app? Right? What is the provenance of this app? And how do people react, right, to this app? How does society change, or is there a reaction to this app? And it gives us a lens to talk about things like nudge theory and dark patterns. So in our discussion classes, the discussion class always ends with what I call a table talk activity. Table talk activities where so students are assigned a table at the near the beginning of the term, and they stay with this table for the rest of the semester. It always includes members from their project group. So I take project groups and sort of glue them together so at least they have sort of consistency throughout the term. And each table is then assigned a role or question for a roughly 10 to 15-minute discussion period. So they go and discuss this, and then a speaker is selected to present the findings to class or to summarize what they talked about. And then a scribe records their notes and just sort of pastes them into the class forum. Um, This particular idea was actually inspired by Robin's role play exercises in the social implications of computing course. So this is an example of one of the tabletop activities for this story. So you can see we give the tables letters. Some of the tables are assigned as testers. Some of the tables are take the role of a rival startup. Other tables are like an ethics review board. Oh, spoilers, like the turns out the app comes from a university. Um, yeah. So we use this as a way for the students to sort of envision themselves in different roles, right? To take different perspectives about a particular issue. We also make extensive use of polls as part of the class just to get a little bit more engagement out of the students. People usually very enthusiastically vote and then discuss about the polls, which is great. We also use it as a kind of attendance taking device. And the results of the course is that it's done well, right? The students like it, and students often report looking forward to taking the course and actually include it in their planning for when they want to take this course. Unfortunately, the course hits enrollment capacity very quickly, so sometimes students don't get in when they would like. I had a student come talk to me last semester. They got into the course and they were relieved because they've been trying to get into the course for like 3 years. Um, but the real goal here is it's great that the course is well liked, but the real goal is durable learning. Right? Do the students remember these ethical concepts when it comes time to use them, right? When they are in the workforce or are in decision making, some kind of decision making role, right? I showed this slide at the end of the course on the very last day, um, that they've shown up, they've attended, they've done the readings, they've engaged with material. But really, like the thing they need to do to get the most out of the course is to put it into practice, right? That's the real goal of the course. And so I surprised them with an extra reflection activity. So we said there were 5 reflection activities. I throw this up on the last day and say, surprise, there's one more. There's number 6. It's due in the future after the semester is done, right? So I asked them to, it's an optional activity. They put in their email and I will contact them sort of 2, 3 years down the road and ask them what they've done with this course, right? Like what did this course have an impact? Because I would personally like to know. And I've had a couple of these come back now because I started this in 2020 and anecdotal reports, I mean, there's some self-selection bias on who signs up for these and who replies to that email, right? But it is effective for some students. Some students say that there are parts of the course that do stay with them years afterwards, right? These are generally students that are in a workplace now because it is usually 2, 3 years after they take the course, which is an upper year course. Some students report that they are very conscious of privacy in the systems that they manage, and that privacy is one of the major topics in the course. Others become much more critical about claims from software companies and what their software claims to be able to do. And a few have actually decided to pursue advanced degrees, sort of real in sort of related areas, which is great. So, using fiction in AI ethics, I think this is very effective because the world is messy and complex, and the fiction helps mirror this. It reminds students that these technologies are not deployed in a vacuum, that they affect real people, and that different people have different perspectives, and viewing things from different perspectives is very important. So, next for the next part, I'm going to talk about stakeholders, right? So it's one thing to be able to understand different stakeholders having different perspectives, but can we help students understand what it feels like to be a stakeholder? I'm going to just jump into the second part where I talk about my multi-agent systems course. Again, this is a cross-listed course, which means it's a research course that has both undergrads and graduate students in it. So returning to the prisoner's dilemma, right? It turns out you should always just rat your friend out, right? If you look through like the what I call the payoffs, right? The number of years you get in prison, you're always better off ratting your friend out. So like if you're let's say you're the role player or the orange player, so you could either, so let's say your friend in quotes, rats you out. Well, you ratting them out gives you 5 years in prison rather than 20 years in prison. So that's an improvement. If they remain silent, you're still better off ratting them out, right? You're still better off ratting them out because you get 0 years. You just get to go free rather than spending 1 year in prison, right? But of course, so that eliminates the so you should not remain silent. You should always rat your friend out. But of course, your friend is also making the again, your friend in quotes is also making the same reasoning, and so they will also want to rat you out, right? And so now we end up at in some sense, the worst configuration for you, right? You both rat each other out and you both go to prison for, a moderately substantial amount of time. Right? This is what's called a Nash equilibrium, and we define it formally, do some math with it. But it says that it's a situation where no player has any reason, any incentive to deviate, to change their action, right? Once you've landed in this particular configuration. So we should always sort of betray the other player in prisoner's dilemma. But but that's not what happens in practice, right? There are experiments to verify this. One way to think about it is that, well, that's not, you never actually just play once, right? You usually are in real life situations much more complicated. Usually you see, some degree of cooperation. One-off interactions are relatively rare. There's an extension of this, right, called the repeated prisoner's dilemma. And there you do have sometimes more cooperation. And so you could be in this configuration where you repeatedly play the game, you're both remaining silent, or you're both cooperating, and then suddenly you're betrayed, and then you're like, oh no, what happened, right? Like, what do you do next, right? Well, it's not clear what you should do next. So there is this gap between sort of the theory and the practice. And the course has a very strong theory of components, basically half of a math course, half of a computer science course. And it's one thing to be able to define what a Nash equilibrium is and calculate what a Nash equilibrium is. But it's something different to be able to experience the equilibrium conditions, right? Or to experience a failure to reach the equilibrium conditions. That gives you firsthand knowledge of what it means to be in one of these systems that maybe you will be designing in the future. And this becomes, again, particularly important as we look to be implementing these systems. So enter experiential learning. Experiential learning is is a pedagogical technique where the learner is placed in some scenario, some situation where they get to experience things firsthand. And experiential learning has a lot of things going for it, right? It helps exercise and reinforce different concepts in scenarios that are relevant to the student's future, right? And so it turns abstract concepts into things that can be applied, can be transferred to potential future scenarios. They are memorable learning experiences, right? Which again leads to more durable learning. Um, and this particular implementation we'll talk about is also narrative based. So there's a story associated with it. It's embodied, so the student's actually running around doing things, and it's unplugged, right? It uses no computer, doesn't really use no computing devices. There's like a projector in the background, but it basically is using no computing devices. So what are some of the problems we're trying to solve with this activity, to sort of make it more clear? In order for game theory to work, the stakes have to be real, right? The stakeholders have to feel something is actually at stake because otherwise it's easy to play prisoner's dilemma in a classroom like, oh, everyone cooperated because nothing was at stake, right? So this particularly memorable quote applies to a slightly different scenario, but I think is a good one here. Goods in a lab are not really consumed by the participants, but only serve as a temporary substitute for money. And when there's not even money to be substituted, right? Like it really is not, if you don't have real stakes, you can't really do game theory with it. The second problem is one that we've alluded to. The world is messy, but the math is elegance, right? The math is so clean, but like sometimes it just doesn't work in the real world. There's could be misinformation or disinformation. There could be time or social pressure. There could be some degree of trust and mistrust, reputational effects in play. Other parties might not have motives that are known to you, right? There's this idea of cooperating, but that you're also kind of competing with each other. Um, so we want a way to showcase limitations of theory. So enter games, right? There's this idea called the magic circle of games. It's first proposed by Dutch historian Johan Huizinga. And he says that different rules apply in games than they do outside of the game, right? You would, for example, be much more likely to betray a family member in a game than in real life, I hope, right? Um, and to step into the game is to become beholden to those rules instead. And games provide sort of what's called an alibi for interaction. They provide the kind of excuse to explore different parts of sort of the action space, we call it, right? To try out different actions. And so the game setting itself can provide meaningful stakes for the participants, right? And then these are as meaningful as you can really get without there being actual consequences outside the magic circle. It turns out that when we do put players in these games, that they do care about them a lot, right? Player participants come to care a lot about these games while they are being played. And the game also serves as a source of chaos, right? There's a lot of things happening at the same time, and the magic circle allows players to interact with each other in ways they would otherwise maybe be hesitant to interact in that way. So the games that we turn to are what we call mega games. If you've played like a LARP or been part of like a model UN, that's this, right? This is both of those things. It's a high player count activity. It takes a full day. We do it on the weekend. We do it on a Saturday. The game is highly themed, so there's always like a story associated with it, and usually has some social component and also a resource management component, right? There's like a board game and there's like a little model UN thing. It's very similar to wargaming or strategic planning exercises. Those are basically mega games, but you do it for serious things. So the one that we use is a product called, it's a commercially available product called Den of Wolves, where the players assume the roles of officers, leaders within sort of a ragtag fleet of ships that are fleeing from some kind of unknown threat with the last remnants of humanity. And if you think that sounds familiar, it's probably because you've seen Battlestar Galactica, right? That also might mean that you are old, as we found out. And if you do the math, it turns out undergrads generally don't know what this is. Um, so for the activity, the players are divided up into different groups, have different affiliations and priorities. Each group is kind of encouraged to manage. Each group corresponds to one of the ships in the fleet, right? And they need to manage their own resources, and resources are scarce. Each ship has kind of a specialized role within the fleet, so they have to negotiate to sort of figure out how to get resources and how to manage sort of maintenance and repairs and defend the fleet. And so we use 3 to 4 facilitators. We did this in 2 different years. And we did it with a local organization called Ottawa Mega Games, who are experts at doing this sort of thing. Um, and it takes the product actually kind of runs itself once you sort of like have a handle on things once you've done the teach, which is great. We announced the activity at the start of the semester because it does take place on a Saturday, and there's an alternative assignment available to students who cannot or don't want to participate in it. So we end up having about 50% participation in an optional activity, which I think is quite good. And so we've did 2 cohorts of 20 students each, right, for 2 different years. And we filled the remaining slots. We need about 40 to 43 players to play. So we filled the remaining spots with members of the public. And they are paying members of the public, so they actually pay for a ticket, whereas the students get to get in for free. So it's quite nice for the students. And we're able to do this because we do this on campus using sort of the student-run pub as our venue. We're able to do this revenue neutral, where we never actually need to spend any money on this activity because the ticket costs pay for everything else. So I can skip over what it means to run the game. And basically, the facilitators kind of throw different problems at the players to keep them on their toes. But the players really are just managing sort of some kind of like resource economy and trying to negotiate with each other. Um, so here is what the game looks like. This is our campus pub. And here the players are roughly in their little groups, right? We can see like on sort of the diagram, a cartoon on the right, that there are different players. There are some student groups and then some members of the public. And then once the game gets going, it's just completely chaotic, right? People are all everywhere. People are trying to talk to people, trying to track down different people to talk to. And they're trying to fend off here. We have they're fending off attacks on the wolves. We have a facilitator on the left, sort of managing sort of like a light dice game. And then here we have the what is essentially the model UN right here as a fleet council sort of arguing over what laws to enact. Right? And anecdotally, players become really invested in their roles, right? We were really successful in making the stakes feel real in the moment, that they care that their ship is doing well. They get really upset if another fleet or another ship singles them out, right, for some reason or another, or slights them, or their plan doesn't work. Um, and so this comes with an assignment, is a summative assignment in the sense that it applies, we want the students to be applying concepts from the class to analyze their activity from the game. So we ask them certain questions to try to get them to use the language of the course. And so do they do that? Yes, right. We use qualitative analysis. We use thematic analysis, which is a technique standard in HCI and social science to um, basically understand what is being written in the assignments and decode them at a shallow level, which is to say, do they use the terms? And for me, do they use the terms correctly? And the summary is yes, they do use the terms correctly, right? Here's them using sort of very standard game theory formulations. Um, I'll highlight this bottom left part, right, where that I haven't actually highlighted in text. I'm highlighting verbally that TFT, which is tit for tat, is a standard repeated prisoner's dilemma strategy. It only works well when you have information on other people's incentives. So here is some recognition that they don't have enough information when they play the game to apply sort of naively a basic concept in game theory. Right? Here is them engaging in strategic voting, right? Really thinking about what the other people are reasoning about what the other people are reasoning about, right? And of course, there's a lot of mention of the chaotic nature of the game. Right? There's time pressure, there's social pressure. There are different things that are preventing them from applying cleanly the mathematical model. And so I think that the activity succeeds in this goal, that it establishes, it helps students appreciate this multi-agent perspective, right? They clearly think about sort of what I call second order effects, right? That they can cause an effect and other people can react to what they were doing. And sometimes you can have some control over it, right? So that there is an appreciation for the fact that their actions will change other players' behaviors. And many of the students' submissions also acknowledge that their own models that they have formulated are have limitations, right? When confronted with sort of this chaos of play. So they do appreciate that even in this game, right, that the game is messy and the world, hopefully they realize is even messier. And just in the last iteration, based on actually review feedback from that paper, we implemented a different alternative assignment where we basically asked the students to do the same activity. So for people who are not participating in the game, to apply it to some real world scenario of their choice. Right. So they pick some real world event and then they go, can they apply game theory to it? And then I didn't compare them because I don't have ethics approval to do that yet. I have to get ethics approval to do that. But just based on impressions while I was grading them, the non-experiential learning condition students were really, really simple in how they formulated their replies, right? They're saying there are several that compare, and this was earlier in the year, so or I guess last year. So they were talking about the trade war, right? The tariff situation with the US, they were comparing that to like a prisoner's dilemma. I'm not even sure if that's like a correct comparison, but they're trying to apply this very simple game form to a very sophisticated, nuanced situation. Whereas the experiential learning condition, we do see much more deeper reflection about sort of the messiness of the world and the limitation of their models. And kind of as a happy bonus, this was really a community building event as well. The local organizers were very enthusiastic about being able to get this rolling. They had kind of stopped because this is a large group in-person activity during COVID, and so we helped them sort of rebuild the community after COVID. And it's become something of like an annual event that people like look forward to every year. I have students that are coming. I think I have at least one student who has been at every single event since I've started hosting them, which was started virtually. So people do get very enthusiastic, and it possibly helped with conversion to graduate school programs, right? I have one student who became a grad student because they were very interested in this, became one of my TAs. Um, and students do talk about things that have happened in the event like years later in conversation, which is great, like a different form of durable learning. So just to kind of wrap things up, AI technologies increasingly entangled with every aspect of society. And I think that this multi-agent perspective can help people who will make future technologies that we will use make more responsible technologies. And I think fictional stories are a great way to help them see, sort of develop their moral imagination. And experiential learning could also be a great way to sort of further establish this. So thank you for giving me the platform for talk about this. I'm happy to answer questions.
Alan, thank you very much for this great talk, and what a interesting topic and approach that you've got to tackle this. So we really appreciate you giving us your time.